Hi, my name is Vincent, and I am a machine learning engineer over at Explosion. And in this video, I'm going to dive a bit deeper in the problem of detecting video games in text. And in particular, when I see a sentence like, I enjoy playing Minecraft, then I would like Minecraft to be detected as a video game. Now, in order to train a model that's able to do this, I do, of course, need to start by annotating some data. So what I'm thinking is that I want to have a system where I have a labeling interface, and if at all possible, it'd be nice if I can have these video games pre-filled, so to say. So the goal of this video is to show you a trick that works quite well for video games, and it will also work quite well for many other named entity recognition tasks, and that is that I'm going to be using Sense2Vec for this. Sense2Vec is a library that contains interesting embeddings that we've developed here over at Explosion. But I would also like to explain in this video why this particular tool works very well for video games. But in order to do that, I might first need to explain to you what makes video games actually kind of tricky to detect in the first place. So to make everything a little bit more tangible, I figured I would just load an example into Prodigy. And here I have the sentence, hey, do I need to have a disc for Star Wars Knights of the Old Republic to play it? And in this particular case, Star Wars Knights of the Old Republic is indeed a video game, so I can just select that and this will be a valid annotation. But I would be interested in having some sort of system that can pre-highlight examples like this. So the next question then is, how might we be able to pre-highlight this? And there's a couple of things that we could do. One thing that we could do is we could maybe check for all the known video games out there. You could, for example, go to Wikipedia, and there you will find long lists of video games that were once on Xbox, Xbox 360, etc. And what we could just go ahead and do is make a copy of all the titles shown here and check if those substrings appear in our text. And to some extent that could maybe work. We are going to have to think about some spelling variations. Another thing to be aware of is that a user might type a colon here, so there might also be some extra punctuation that users write that we are going to have to account for. But okay, you could say that's a way to get the ball rolling. But in practice, if you do that, you're actually going to be missing out on a lot. And one of the big reasons, at least in the case of video game texts online, is that people like to write abbreviations. So again, someone is talking about Star Wars Knights of the Old Republic, but in this case they're going for this very popular KOTOR abbreviation. And the thing with video games is that these abbreviations are actually very common. And a downside of a pre-existing word list is that it might not be able to capture all of these different abbreviations and variants of these abbreviations, which means that we might still be missing out on a lot of titles, and that's not something that we want. So we're going to have to deal with a couple of challenges. One of them, as we just mentioned, is abbreviations. Another interesting aspect is that we sometimes have very long titles. And long titles can be annoying because if we want to do something with word embeddings, the longer a title is, the harder it might be to take the mean of all the embeddings and have something meaningful come out. With very long titles, some of the useful context might just evaporate. And another somewhat awkward thing is that if I take a title like Knights of the Old Republic, the word embedding for knight and republic, I mean, we are really interested in the phrase itself, not so much the individual words in the phrase. And that brings me to the next point, which is that video games are quite domain specific. If we have word embeddings trained on the news corpus, can we really assume that it understands everything about video games, or is that maybe a stretch? So let's now talk about Sense2Vec, and let's also talk about how Sense2Vec is able to address these challenges. So what is Sense2Vec? Sense2Vec is a Python library that you can install yourself on your own machine, and what you're looking at here is the official Explosion blog with a code snippet of the library. The way it works is you're able to download these pre-trained embeddings, but these embeddings are different than embeddings that you might be used to. Normally, a text embedding is a mapping from a word to a vector. But Sense2Vec does just a little bit more. In Sense2Vec, a word can have context. So for example, you can have the word duck, and you can say, well, I want that in the context of it being a verb. Or you can say, well, I want that in the context of being a noun. And this helps disambiguate two different meanings in the same token, which is very nice. But Sense2Vec also does something extra. And that's demonstrated in the query over here. You'll notice that, again, we are adding context. This is a noun. But you can also see that we are now dealing with a phrase. Natural language processing. Those are 3 words or 3 tokens, but Sense2Vec actually tries to encode entire phrases as well. So in Sense2Vec, we can still expect lots of these contextualized words to have vector representations for them. But what makes Sense2Vec interesting for our use case specifically is that we can get the same for phrases as well. And when we think about a video game, Knights of the Old Republic, that can now be stored as a phrase as well. And that also brings me to the pre-trained embeddings that we can use, because these embeddings are trained on Reddit. Reddit is a very large online forum, and it has lots of subreddits or subforums that tend to be quite domain specific. And the benefit for us is that we can expect there to be subforums for video games. And because Reddit is on the internet, you are going to get users that type with internet spelling, which also implies that we might expect to see a lot of these abbreviations that we're interested in. So what I'm going to do next is I'm going to explore Sense2Vec using the online demo that we're hosting, and hopefully just that demo will convince you that indeed it is going to help us in our use case. Alright, so here is the Sense2Vec demo that's hosted online that you too can interact with. And you can see here that when the phrase natural language processing is given, that then the similar phrases are machine learning, computer vision, deep learning, and these are all sensible suggestions. What I can do is I can take the embeddings from 2015 or the more recent one, 2019. But here I can also start filling in maybe something with the reference to a video game. So I could fill in, for example, the KOTOR abbreviation. And when I do that, I see some interesting results. The Knights of the Old Republic phrase is in there, along with some variations of spelling. And here I can also see some other Star Wars related video games like Republic Commando and the Old Republic. I just happen to know this. But what I can also do is just click the phrase that's listed over here, just to see what Sense2Vec would make out of that. And quite nicely, I would say here, it's just able to fetch abbreviations. So that's definitely great. But I can also give it some other video games. Maybe Minecraft. And when I do that, I get different spellings from Minecraft. I also get related games that are similar. Let's maybe try one more. Maybe Halo 4, let's say. And when I do that, again, it's able to come up with lots of variants of the Halo video game. So I am getting the impression that this indeed is a tool that I'm going to be able to use for my video game problem. And as luck would have it, Sense2Vec doesn't just come with a Python library, it also comes with a spaCy integration, so you can use it from spaCy if you like, but it also comes with a couple of Prodigy recipes. And just to preview that, I'm at the Sense2Vec GitHub page, and here I see a link to some annotation recipes. So let's click that. And then in the README, I have this list of recipes that are at my disposal. And in particular, we have this Sense2Vec.teach recipe. This is very similar to the terms recipe, but instead of making a terminology list just on single tokens, we can use Sense2Vec to build a terminology list with full phrases. So what I'm going to do is set that up. Alright, so I am now inside of a terminal inside of Visual Studio Code, and I am going to run Prodigy. And from here, I will refer to the Sense2Vec.teach recipe. And just for good measure, I'm going to call help first just to see what inputs it expects. There we go. And when I do that, then I can see that there are a couple of arguments that are going to be relevant. For starters, I will need to give a name for a data set, and then I will need to refer to the path where my pre-trained vectors are. I downloaded these vectors off camera beforehand, but I will need to refer to them. And the final thing that's going to be important for us is that we pass along some seeds. These are the phrases to start with. And from there, Sense2Vec is going to try to find similar phrases which we can then use to build our phrase list, so to say. So as we just saw, I first need to pass it a dataset name. So my video game data, that ought to do. And then I need to give it my path to the pre-trained embeddings. And there we go. And then finally, we need to give it some seeds. And I think, just to get started, let's give it KOTOR, maybe Mass Effect, that's also a video game, and maybe Halo. And this is probably enough for us to get started with. And this takes a little while because Sense2Vec does have to pre-calculate some things on our behalf. But here we go. Knights of the Old Republic, that is a phrase that I can consider. And I think this one would be accurate, so I can hit accept on this one. It's now mentioning Dragon Age, which I think is a reference to another video game, so that's also good. Jade Empire, sure. So this is one that I think is just a little bit interesting. ME1, I think, is referring to Mass Effect 1 in this case. And that's certainly something that could be valid for my use case. But I do want to emphasize that this is just a behavior that I do appreciate because it's giving me abbreviations that I myself might not have come up with. So that's great. After labeling for a while, I hit the first item that really makes me doubt, which is this one, Star Wars. I think Star Wars on its own is a reference to the movies. And while I can imagine that there are lots of Star Wars games out there, I think that this one's just a little bit hard to use as a reference to a specific video game. So this is an example that I am going to reject. Oh, and this one is interesting as well. I saw a lot of examples where I had the abbreviation KOTOR and then A2. But of course, what some people like to do is just put 2 bars or 2 L's here to denote number 2. So also something I probably would not have come up with myself, but valid, so that's good. Right, and this is an interesting one too. So in this case, there are lots of video games that appear in trilogies. If I'm not mistaken, Mass Effect, I think, is one. Maybe this is a reference to Halo back in the day that there were 3 video games. Either way, original trilogy is too vague. It might, in the end, refer to a video game, but it's not an actual video game itself. So I'm going to reject this one as well. So at this point, I've been labeling for a while, and even though I do want to admit that there's definitely more examples that are of interest, I am noticing that I am getting video games from a very specific genre. These are the shooter role-playing video games, as it were. And I think it might be fun to demonstrate what would happen if I just pick slightly different seeds. So I'll hit save and then go back to the command line. I will now shut down Prodigy. And as a seed now, I'm just going to give it FIFA 18. Just to see what would happen when we give this as input. And when I do this, I get FIFA 19, 17, 16, normal FIFA, 15, and etc. So we can see that the C terms that you start with do tend to matter quite a bit here. Let's see what happens when we exhaust the version numbers. So that's interesting. After I've exhausted FIFA a bit, then I get another abbreviation, PES18. I had to look this one up, but this refers to Pro Evolution Soccer from 2018. So this is still a reference to a video game, but now we are definitely more in the sports realm, so to say. So even though this approach is pretty interesting, I do want to take a step back and maybe perform a trick that's going to be just a little bit more pragmatic, because there is a slight issue that I have with this approach, even though it's doing a couple of things that I do really like. So let's take a step back and consider on a more higher overview what it is that we are currently doing. So currently I am using Sense2Vec, and the way that I'm using it, I am giving it some seed phrases, and then Sense2Vec can give me phrases that might be similar and that I should take into account. And the thinking here is that this is going to be a very long list of phrases that I can use to pre-fill my dataset. But maybe there is where we do have an interesting problem. Because you could wonder if the phrases that we find here, do they actually appear in our dataset? It could be, for example, that we don't have any FIFA references in our dataset, but we might be spending a lot of time generating phrases here that we are not going to be using, and that is something to be just slightly aware of. Now, it can still be a good thing to have a very long phrase list, because if we ever get new data, it will be nice if we have a pretty broad list. But since we are getting started now, we might want to flip this the other way around. Instead, maybe we want to start with the dataset that we have, and maybe we want to loop over all the phrases in it. What we can then do is pass all of these phrases into Sense2Vec, and from here we can say, well, if there is a match, then we might have a phrase of interest. And the main benefit of this approach is that I do know for sure that any of the phrases that I will get over here actually do appear in my dataset that I started with. So as a starting point, this might be just slightly more pragmatic. We do have to think a little bit about what it means to match, though. The way that this is still going to work is we still need to have some sort of reference phrases over here. And what we can then do is we can say, well, we have a phrase of a seed and a phrase that we are considering. Both of these have a numeric vector attached from Sense2Vec. And if the similarity between those two is pretty big, then we can say that we are talking about a match. So in practice, if we have a very high cosine similarity value, then we can consider them. So what I will do now is I will just show you a script that does this, and this will allow me to generate a sequence of phrases of interest, which I'm then going to annotate inside of Prodigy. All right, so I'm back in Visual Studio Code now, and here is the script that extracts all the useful phrases out of a JSON-L file. The main bulk is happening in this one function called scan file. It accepts a JSON file with examples to consider, a path to the Sense2Vec vectors, some queries with phrases that are interesting to me, so this is where I'll pass a couple of video games into, and then I also have to pass it a file where I can save the phrases of interest into. Now, I'm not going to go into all the details in this script, but there is this one feature of Sense2Vec that does deserve a bit of extra highlighting, and that is that you can actually combine Sense2Vec with spaCy. So here you can see that I'm loading in a small spaCy model, and what you can then also see is that I'm attaching a pipeline component, namely a Sense2Vec component. I'm then also making sure that that Sense2Vec component is being hydrated with all the vectors I have on disk, but this now also means that I have Sense2Vec properties available from this NLP variable over here. And that is going to prove to be quite useful. So below here I am initializing some extra things. So I have this variable called blob that just contains all the examples, and I also have some things I want to keep track of. So there are these terms of interest that contain all the phrases that I want to output, but I do want to prevent that I consider every phrase every single time. So I'm also keeping track of phrases that don't have to be considered. And I also keep track of all the distances of all the terms that match. And then here in this big for loop, you'll notice that I'm using nlp.pipe to parse all the text in the examples from the JSON-L file. So that's generating lots of spaCy documents. I'm looping over all of them in this outer for loop over here. And then this document, because this NLP object has the Sense2Vec component, it also has this one extra property, S2V phrases. And these are all the phrases that Sense2Vec has been able to detect in this document. And what I can then do is I can take every phrase in that document, and I can take every query from my queries list, so those are the video game names that I pass in up front, And then I have this one function over here that handles all the similarity comparisons. And if this function finds a match, it will then update the terms set, the not terms set, as well as the distances. But the whole reason I'm able to do this is because I'm able to use Sense2Vec together with spaCy, and it's these phrases that are being detected that are going to be very useful, because these are phrases that actually appeared in my data, and those are going to be phrases that are very interesting to annotate. So once I've looped over all of those documents, eventually I will have this long sequence of terms and distances, and as a final step here, I am saving those to disk. So I've skipped over a few details here, but hopefully this is enough context. If you're interested in the details, the full code, including this function, can be found linked in the show notes. But what I'm going to do now is I'm going to call this function from the command line now. So there we go. I have my scan script over here. The first argument is the JSON-L file, just like this function dictates. Next, I am passing the pre-trained embeddings. Got the path there. Then the queries that I'm giving it, I think I'll just start with KOTOR, Mass Effect, and FIFA 18. Those seem like sensible things to start with. And then the output file is going to be phrases.jsonl. When I start the script, I get some output. And once everything is done loading, you'll notice that a progress bar appears. What you're looking at here is the progress for going through all of the documents in this file. This will take a while, so this would be an excellent point in time for me to grab a drink. But the whole point here is, of course, that once this is done, we can start annotating in Prodigy, and we should have Sense2Vec matches that are pretty interesting. All right. Indeed, after a couple of minutes, this script is done running. And it's created a file called phrases.jsonl, which I've opened over here. And here we can see some of the phrases that it has found, together with a confidence value. And there's a couple of games in here that it's been able to capture. This is a video game. I believe this is a video game as well. Fallout, that's a series of video games. But there are a couple of items that are not going to be relevant. So this term mobile games, for example, that's not referring to a specific video game. Multiplayer content, same story. So even though I'm pretty sure that there are going to be video games in this list, I will need to actually still go through them and actually annotate them. So let's set up Prodigy for this real quick. I'm calling Prodigy from the command line here. I think just doing text classification is sufficient for this data. The dataset name is my extra video terms. I am giving it phrases.jsonl, this file, for it to label. And I'm going to attach the label game. And I'm just going to do some text classification with this. All right, so I'll start labeling here. And when I see some interesting examples, I'll just pause and reflect. So this was an interesting one. Looking at FM5, you do get the impression that this should be a video game, but I have no idea what it is. So I Googled it, FM5 with Xbox attached, and then I learned that there is this video game called Forza Motorsports 5. So there you go, that's pretty cool. Another abbreviation was found in my dataset. So I think this one's interesting to mention, just because PlayStation is obviously like a term that's very much game related, but it's not an actual video game. So Sense2Vec here isn't so much a thesaurus per se, but it is still pretty good at capturing the vibe that I'm going for, which I just think is interesting. That said, this is not a video game, so I'm gonna reject this one. Yeah, so this is also an interesting one. So DLC stands for downloadable content. And I presume that the S here is trying to make it clear that we're talking about the plural of that. So a DLC can be interpreted as a video game. It's like an expansion pack, but then I would need to know the name of the DLC in order for it to be a proper video game reference. Again, definitely in the realm of video games, but not an actual video game, so I'm gonna reject this one. So I think this is also a nice one just to briefly mention. So Halo Master Chief Collection, that's a very specific version of Halo, I suppose. But the main cool thing here, at least I think, is that we have a phrase of 4 words here that Sense2Vec has been able to detect for us. So that's a relatively long phrase, but Sense2Vec was still able to spot it. So that's just nice. I will also accept this one. All right. So it seems like I have exhausted the phrase list. So if I have a look at the statistics then it seems that it's not quite 50-50. It's a bit lower than that. But this little exercise, which didn't take me that long, did give me about 180 video game references that actually do appear in my data. So that's actually not bad. I'm actually quite eager to play around with this now and see what it found. But what I am going to do now then is I'm going to merge the 2 phrase lists that I have. So I have this phrase list that I made with sense2vec.teach with that recipe. What I can do is use the sense2vec.toPatterns recipe. And this is going to generate a patterns file that I can use in another Prodigy recipe from the original Sense2Vec recipe. But then I also have my custom recipe that is looping over my actual data. That generated a phrase list which I have just passed through this text classification. So I'm going to be using a custom script to make sure that these patterns, as well as the patterns that came out of this, are just in a single JSON-L file. The code for this will be shared, but it's just a bit of boilerplate. So I'm going to do that off screen now. And there we have it. I now have the single large file that has all the patterns from both approaches. And you can also confirm here that these patterns span across multiple tokens. So that's definitely nice. So what I'm now going to do is I'm actually going to use these patterns to try to pre-highlight some named entity examples. And to do that, what I've got here is a NER manual recipe that is going to populate a data set called video games. The recipe dictates that you have to give it a spaCy model because it needs a tokenizer. I'm just giving it the blank English tokenizer here. Then I need to pass it some examples, which is this JSON-L file. And here is where I'm using the patterns. This patterns file is now being passed along with this patterns flag over here. And it's these patterns that will also be used by this recipe to generate these pre-filled highlights. One thing to keep in the back of your mind is that you are also interested in attaching a label, and you will need to make sure that the label that you pass along here corresponds with the label that is attached here. So far so good though, so I'm going to start annotating. And this is now the annotation interface, and we can see that indeed some things have been pre-filled. Notice that we also get a little bit of metadata, so this is a pattern and this is a pattern that's being applied, and we can see on what line numbers these patterns appear. In this case though, I think it's made an interesting error because the full name of the game is Assassin's Creed Origins, and in this case the apostrophe S isn't taken into account, so let's just fix that. That looks a whole lot better. Now, one thing that's pretty cool about this is that the highlighting, even though it was wrong, it did get my eyes to look at the right point in the annotation screen, so they still definitely helped. But I think that this is now correct, so I can hit accept. Right, so again, my eyes are going to the right spot, but we also see that it's made a slight mistake here. Forza Horizon, yes, that is the video game, but we would like to have the number attached as well, because the absence or presence of a number does indicate a different game. So the number needs to be attached. This looks good now, though. Now, one thing to remember is that we are, of course, also going to be seeing some examples where none of the patterns match. And that's typically also just a good thing, because we wouldn't want a machine learning algorithm to think that every example has entities in them. So that's just good to observe. So in this case, I can hit accept. Yes, it got this one correct as well. So this is an interesting one too. So in this case, there is definitely a video game in here, but our approach wasn't able to catch it. And that is, of course, something that can happen. Even if we have a very long phrase list made with Sense2Vec, and even if we try to generate our own phrase list using our own data, our methods are not going to be perfect and some mistakes will be made. So we can't assume that everything will be pre-filled. There are also going to be some mistakes. This looks good now, though. Interesting. So this is a good one to maybe wrap up with. There's a couple of mistakes. For starters, it didn't catch Minecraft over here. So that's now fixed. And I think in this case, we want to have Fallout 4 and Forza 7. We do really want to have those numbers attached to the name itself. But there you have it. We do have an approach that in general works pretty okay. We have a pretty big patterns file that is able to detect lots of these video games. And having those patterns is going to make it just a whole lot nicer for me to annotate this data set. And there's still some tricks that I could do from here, but I do think this is a nice point to wrap up this video and to maybe reflect on some of the lessons that we've learned. In this video, we've seen how Sense2Vec was able to help me find video games in text, and also how it was able to just make the annotation experience a little bit nicer. But there were a couple of things that I couldn't help but notice. In particular, I was pleasantly surprised at how good Sense2Vec was at finding these abbreviations. I honestly think that because abbreviations are so well supported, that I might actually catch more video games that I might otherwise not be able to find. So that was definitely a good thing. That said, I do want to take a step back and maybe also think about when this trick won't work as well. At the moment, we are using the pre-trained Sense2Vec embeddings, and these are trained on Reddit. And Reddit is a somewhat unique corpus. It has internet slang on it, and it doesn't necessarily represent all the text that you might find elsewhere. And it might also certainly be the case that there are a couple of domains that aren't as well represented on this platform. Third, we also need to remember that Sense2Vec uses cosine similarities and embeddings to figure out if a phrase might be of interest, and we can't expect that to have a perfect accuracy. We really shouldn't expect that we have all the video games detected now, so we still need to manually annotate to be sure. And there's actually one area where we might also be able to improve the system. If we have a look at our patterns file, then right now we usually have the title of a video game, but maybe we can programmatically add versions to it. That way, we might be able to define patterns such as the first token needs to be FIFA, and the token that follows just needs to be any digit. If we programmatically add these patterns to the ones that we have right now, then I can think we can match more video games more accurately too. Another thing we have to keep in the back of our mind is that the most recent Sense2Vec vectors were trained in 2019. So any relevant phrases or any new video games that came later may not accurately get detected. Now, if this is an issue, one thing that's good to keep in the back of your mind is that nothing is stopping you from retraining your own. And that can be a very valid technique, especially if you're dealing with your own domain and if you have your own training data. But in general, it helps to remember that you probably want to retrain these systems if you're using more and more recent data. But that said, in general, I think that Sense2Vec has a couple of very unique and useful features that can make it easier for you to annotate named entities like video games.